Welcome to the Explainer series for Quant. Here we'll be using very simple concepts and apply it to CAT level problems and solve them as easily as possible.
In this session, which is the concluding part on circles and geometry, we'll look at some more complex questions from circles and their intersection with other circles, triangles, quadrilaterals, etc. I would suggest pause this video, have a look at the question set. The PDF is available in the description of this video. Once you have tried these on your own, then proceed with the rest of this session.
Please do share this with your friends who are preparing for CAT and other MBA entrance examinations. You can like and follow us on Facebook as well as subscribe to our YouTube channel to get live event and notifications for all the updates regarding CAT and other MBA entrance examination. You can also look at our WhatsApp as well as Telegram lists. You can join over there and we will update you. We don't spam over there. If you want, you can enroll for our Quant and LRDI courses. These are the best and the most comprehensive courses available in the market.
This is the last part on the circle series. Till now we have looked at basic properties, lines, triangles and circles, quadrilaterals and circles, multiple circles, and even the first part on complex questions as well. In this session, we will look at, again, these concepts which we have discussed in the previous sessions to solve these questions which came up in the past CAT, XAT and IIFT papers. The first question is from CAT 2006. Let's see what this is. A semicircle is drawn with AB at its diameter. From C, a point on AB, a line perpendicular to AB is drawn, meeting the circumference of the circle at D. Okay, so this is C, this is D. Given that AC is equal to 2, CD is equal to 6, the area of the semicircle will be how much? Now, you need to figure out whether A is closer to D or A is further away from D. Now, can we say for sure that A is closer to D versus B? Right. Remember, because it's a circle, each of them will be an isosceles right angle triangle. Right. Any triangle that you draw will be an isosceles right angle triangle. The best CD can do is be equal to the radius. Right. Otherwise, all the other values of CD will be lesser than the radius. Right. Which means the radius has to be greater than 6. Now, given that AC is equal to 2, it means that D is closer, AD is lesser than the radius of the circle, which means D has to be closer to A versus B. So we can be 100% sure that AD is 2 and A is closer to D versus D being closer to B. Once you do this, the question solves itself. Question is, what is the area of the semicircle? Area will basically, you will need to find the radius, right? So if I draw a radius here, if I call this R, this length will be R minus 2, right? Using Pythagoras theorem, R square should be R minus 2 whole square plus 6 square. So this will be R square plus 4 minus 4R plus 36 equals R square. R square goes out. If you take this here, 4R equals 40. R should be equal to 10. Now I need the area of the semicircle, not the full circle. Area of the semicircle will be pi into 10 square divided by 2, which is 50 pi. Option B is your correct choice. The options actually save you. There are chances that you might actually take pi into 10 square, whereas you only need the semicircle, not the full circle. Right? Pretty straightforward. Key concept was to figure out whether AD is closer, D is closer to A versus B. Right? Job done. The next 3 questions are a triple set from CAT 2003. Not too difficult. Right? Once you let the, as with all these triple sets, let the question solve itself. Read what is given in the question. Most of the times, they will solve it themselves. Let's see what this is. Consider 3 circular parks of equal size with centers at A1, A2 and A3. So, right. So these are circular parks A1, A2, A3. The parks touch each other as shown below. So you will have equilateral triangles all over the place. So if this radius is R, this will be 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 R. So A1, A2, A3 will be equal to 2R into 3, 6R. That will be A1, A2, A3. We can also find B1, B2, B3. Right. So B1, B2, B3. Right. What will be the part. This portion is R, right? This portion is R. So if I drop a perpendicular, this is 30, 30, 60, 90 triangle. So if this is R, this will be R into root 3 by 2. Similarly, this will also be R into root 3 by 2. So if I combine the full length, it will be 2R plus twice of R into root 3 by 2, which will be R into root 3, right? So one side is 2R plus R root 3. All three sides will be 3 into 2R plus R root 3. That is 6R plus 3 root 3 R, right? That will be B1, B2, B3. What will be C1, C2, C3? For that, we'll need to find this portion. Okay. This portion is R. This additional portion, let's check what it is. If I draw this line here, this is 30 degrees, this is 60 degrees, 30, 60, 90 triangle. So 1 root 3, 2, right? So this portion will be R root 3. This portion will also be R root 3. So the entire length will be 2R plus twice of R into root 3. So 3 such sides into 3. So C1, C2, C3 will be 6R plus 6R root 3, right? That is what is given to you, right? So now let's see what the question says. 3 sprinters A, B and C begin running from points A1, A2, A1, B1 and C1. So A runs on the innermost part, B runs on the middle one and C runs on the third one. Each sprinter traverses her respective triangle path clockwise and returns to the starting point. So A's path is A1, A2, A3, B's part is B1, B2, B3, C's part is C1, C2, C3. Okay, so the first question says, let the radius of each circular path be R. So we have already taken that. And the distances to be traversed by sprinters A, B and C be small a, small b, small c. We have already calculated that, right? Which of the following is true? The following is true. So difference between B minus A is same as difference between C minus B, which is 3 root 3. This actually works out. This is the distance covered by A. This is the distance covered by B. This is the distance covered by C. B minus C is 6R minus 3 root 3R, which is 3 root 3R, right? And C minus B is also 6R plus 6 root 3 minus 6R plus 3 root 3. So this will be 6R root 3 minus 3R root 3, which will be 3 root 3R. Again, this is the same. Option A is the correct choice, right? Once you have a little patience, job is done. The second one in this set uses the data from the previous one. It says sprinter A traverses A1, A2, A2, A3, A3, A1, right? At speeds of 20, 30 and 15 respectively. B's speeds are given as 10 root 3. C's speeds are given. All speeds are in the same unit. Where would B and C be respectively when A finishes the sprint? When A finishes the sprint, where will B and C be? Okay. Now if you look at the distance, we don't know the R, right? We wanted to know the length R. Let's take an R which will be divided by all these values. This is 20, this is 30, this is 15. There is a 40 here, there's a 120 here. So let's take R is equal to 120. Right. So we know the length A1, A2, A3. Now we can calculate the distance covered by A. Distance covered by A will be 6R. Distance covered by B is 6R plus 3 root 3R. And by C is 6R plus 6 root 3R. Right. Now let's see what is given. A's speeds are 20, 30 and 15. So A covers this distance at 20. The second distance as 30. Third distance as at 15. Right. So what will be the time taken? Each length is 2R units. Each length is 2 into 120, 240 units. The first one is at 20 units per second or whatever, 20 meters per second, whatever you want to call it. So that will be 12 seconds. The second one will be 240 by 30. That will be 8 seconds. And the last one is 240 by 15, which will be 16 seconds. So the total time taken by A1, A will be 12 plus 18 plus 12 plus 8 plus 16, that is 36 seconds. So A's total time taken is 36 seconds. Now let's see where will B be after 36 seconds. Okay. Now B continuously traverses at 10 root 3 plus 20. Right. So B's total distance will be, if I take R out, that will be 120 into 6 plus 3 root 3. Speed is 10 root 3 plus 20. So if I take 10 out, that will be 10 into 2 plus root 3. Right, this is 3 times. Right, this is out. 12 into 3 is 36. So B will also complete her path completely. So B will be at B1. So this is out. One of these three is your correct answer. Now, where C is will decide where this ends up. Okay, C's speeds are for the first two parts. From C1 to C2 and C2 to C3, it's 40 by 3 into root 3 by 1. Right, whereas for the third part, it is 120. Okay, so let's calculate how much time it will take to cover the first two parts. Each segment for C will be the total length divided by 3. This is the full length that she has to cover. So each length would be 2 plus root 3 into R. R will be 120. Right. For the first segment, the time is this by 3 into root 3 plus 1. This is 1 plus root 3, sorry. Right. Into 2. Right, this is what it is. This goes out straight away. Right. 3 goes to the numerator. 40, this will be 3. 3 into 3 will be 9. 9 into 2 is 18. So for the first segment, she will take 18 seconds. For the second segment, she will take 18 seconds. So at 36 seconds, she will be at C3. Time is already done because these two complete the race in 36 seconds respectively. So C will be left at C3, whereas A has finished the race, B has also finished the race. Option C will be your correct choice. And the last one is basically on the basis of similar triangles. Let's see what this says. Sprinters A, B and C traverse their respective paths at uniform speeds of U, V and W respectively. So this is speed is U, speed is V, speed is W. Right. It is known that U square, V square and W square is equal to the area A, B and C. Okay. Now the ratio of their areas will be square of the ratios of their lengths. Why? Because they are similar triangles. Which means the ratio of their speeds is ratio of the square of the sides. Side that A needs to run to side that B needs to run square. Which means the ratio of the speeds is same as the ratio of the sides. Right, which means they will run equal segments at equal points of time. So in the same time that A runs from A1 to A2, B will run from B1 to B2 and C will run from C1 to C2. Similarly, in the time that C runs from C2 to C3, B will run from B2 to B3 and A will run from A2 to A3 and so on. Right. Question is, where would A and C be when B is at point B3? So when B reaches point B3, A would have gone from A2 and then to A3 and C will have gone to C3. So since each of them reach the end points at the same time, it is pretty straightforward. A3 and C3, option B is your correct choice. Right. So from these three, second one required some amount of work, but all the work was done in the first one. Once you do this in about 8 minutes, you can solve 3 questions straight away. The fifth question is from XAT 2014. Again, if you draw the circle, your job is done. There are 2 circles, C1 and C2 of radii at 3 and 8 units respectively. The common internal tangent T touches the circles at points P1 and P2 respectively. The line joining the centers of the circle intersects T at X. The distance from X to the center of the smaller circle is 5. What is the length of the segment? So let's draw the circle. Right, I've drawn this circle here. Okay, so C1 is here, C2 is here. So there's a common internal tangent and the line touches the circles at P1 and P2. So P1 and P2. Right. right? So this is 3 units, this is 8 units. Okay. The line joining the centers of the circle intersects T, which is this common tangent at X. Right? The distance of X from the center of the smaller circle is 5 units. So let's call this A, let's call it B. So AX is 5 units. Right? What is the length of the segment P1, P2? Now this is 5, this is 3. So P1X will be 4, 3, 4, 5, right angle triangle. You need to find the length of the segment P1, P2. You need to find the length of the segment P1, P2. Given that these are all similar triangles and the ratio is 3:8, right? P1 to X to P2 to X will be 3:8. Right. So if this is 3 portion, this will be 8 portion. The full length will be 11 portions. 3 portions relate to 4. What will 11 portions be relating to? 11 by 3 of 4. That's 44 by 3. That's between 14 and 15. Option C is your correct choice. Under 2 minutes in an exam situation once you draw this diagram. And the last question is a pretty crazy question from XAT 2011. Now, I'm sure that if you are on online forums, this will be like a direct formula, etc., which will be taught to you. But suppose you don't know that direct formula, let's see what this says. It's not very difficult. All you need to be is a little patient. Draw the diagram, the question solves itself. Consider a square ABCD of side 60 units, right? So side is 60 units. It contains arc BD and AC drawn in the centers A and D respectively. A circle is drawn such that it is tangent to the side AB and arcs BD and AC. So this will be A, this will be B. So the smaller circle is tangent to this and it touches these two arcs. Right? Now the arc AC is drawn with center at okay, so this will be B and this will be D. Drawn with center at D, and arc BD is drawn with center at C. Okay, a circle is drawn. Okay, you need to find the radius of this circle. Suppose this is R. Okay, now the concept that we will be using is basically that if two circles touch each other, right, then the point of contact and the two circles lie on the same line, whether they touch internally or externally. So this is one single straight line and this is one single straight line, or this is a single line segment. This is a single line segment. Okay, once you do this, all you need to do is look at Pythagoras theorem and you'll be able to solve it. Okay, so let's call this length H. It will be a right angle triangle. Right, so if I take, let's call this X, this is Y, this is Z. Okay, so if I take the right angle triangle ZXD, right, the value dx is equal to H, the value zx is equal to R, and the value dz, this full length is a straight line. This is the radius of a circle, right? So radius minus the small r. So you will get 60 minus r whole square should be equal to x square, r square plus h square. Right, now let's take the other triangle ZYC. In triangle ZYC, CZ is the hypotenuse. What is CZ? CZ is the larger radius plus the smaller radius. Larger radius is 60. Why? It is drawn with the side of the square. So 60 plus r whole square should be equal to h square. What will be this length? This length is, this portion is r. So this will be 60 minus r. Right. So this will be h square plus 60 minus r whole square. Now we need to find the value of r. So just subtract one from the other. If you subtract one from the other, it will eliminate h. So 60 plus r whole square minus 60 minus r whole square should be equal to h square. H square will be gone. 60 minus r whole square plus minus r square. right? This is what we need to do, right? So a plus b whole square minus a minus b whole square will be twice of a into b into 2, so 4ab. So 4 into 60 into r. This will be equal to 60 plus 60 minus r whole square minus r square. So 60 square plus r square minus 2 into 60 will be 120 r minus r square. So this r square and this r square goes. Right, so this is 120r, this is 240r. So bring it onto this side. So you'll get 360r will be 60 square. So r will be 60 square divided by 360. 60 square is 3600. This is out, so 10. Option B is your correct choice. Now, in case you want to mug up that relation, if you have a circle like this drawn between two arcs inside the circle, if the side of the square is capital R, the length of the smaller circle will be R by capital R by 6, 1/6 of the side. But again, this is just for information purposes. Even if you don't know it, in an exam situation, you can derive it if you want to. As we saw, questions regarding circles, etc. Basically, you have triangles inside a circle, squares inside a circle, rectangles inside a circle. Any of these cases, basic properties still hold good. Find the right angle triangle, find the equilateral triangle, find the isosceles triangle. Job is usually done. Apply Pythagoras. Question solves itself.
That completes this particular session. If you liked it, please do share it with your friends who are preparing for CAT and other MBA entrance examination. Please do subscribe to our YouTube channel as well as follow our Facebook page. The links for our course are available on the description to this video. Till we meet again the next time, goodbye and all the best.